Hello, my name is Paulina Jimenez, and I will be doing my video project for my molecular model and chemical information class on dihedral angles. I will be programming how to do dihedral angles on Netbeans. First, what we will do is that we will add a menu item into our screen modes. I already added mine, which is angles, so I don't need it. Once we implement it, we will rename the menu item to angles, and then we can also change it to angle so that it will be easier when we go to the source to actually find it. Then we will right click and go to events. We would go to action and action performed. Okay, so once we do that, we would go to the source, and then we would find our angle menu item, action performed, and we will implement the code of my panel to period set mode to angle. Once we have that ready, there's no more need to implement the code here anymore. So we will go to my panel. Once we go to my panel, we would implement the select electrons equals new electron 2, meaning that we would select 2 electrons to know the angle of, and then we will name the function which e, and it would be equal to 0, and float angle would be equal to 0. So we would start our angle at 0. Then we will come down here to paint, and as you can see there, we had already had this code of parallax implemented. So we can do is copy that, and then at the end just add instead of parallax, we could add angle is equal to plus angle, comma 0, comma get height. Okay. So once that is drawn, we can get the angle of 2 electrons. Then we will come up here to mouse press, and this is where we actually would implement the math that goes into the program that would allow us to click on 2 atoms, and then it will tell us the angle of those 2 electrons. So we're gonna write else if mode parentheses mode period equals angle, and then we will come to here, that is electron is equals to which electron press point, meaning the electrons that we will press to find the angle. And then we'll put if electron equals null, select electrons which e is equal to electron, and then which e is equal to parentheses which e plus 1 close parentheses, and this sign that you see here would be sort of a remainder, would be called the remainder, and our remainder would be 2. So then we would continue with if select electron 0 is equal to null, or select electrons 1 is equal to null, then select electron 0 is equal to select electrons 1. Once we have that, we will start implementing the code for our 3D angle. This will allow us for the program to tell us the angle at a 3D scale, and we would implement x, y, and z. So here we would have x1 is equal to select electrons 0 minus select electron 0. So that's what we would implement for each one, for x, y, and z, x1, y1, z1, and then we would implement the same code for x2, y2, and z2. We would just make sure that this is electron 0, because we would start 0, and then this would be electron 1. So we would have electron 0, and then we'll have electron 1, and then z will be our electron 2. So once we do that, we would go to floats apps 1 is equal to floats times math square root of x1 times x1 plus y1 times y1 plus z1 times z2. Okay, and we would do floats apps 2, and it would be the same, only with x2 times x2 plus y2 times y2 plus z2 times z2. Okay, Then what we're going to do next is that we're going to use the dot product, and this is where everything that we learned in our math classes come in hand. We would implement the code float dot equals 2x1 times x2 plus y1 times y2 plus c1 times c2 divided over abs1 times abs2. Okay. So then we're gonna set the angle, which normally we will set the angle is equal to cosine arcsine times in parentheses a times b over the absolute a times the absolute b, and that would give us our answer in radians. So then we actually want angles. So since we want angles, we would have to multiply our answer times 180 divided by pi, and that would give us our angles. So this is what the code that we implemented here. Angles is equal to float times math of our cosine dot, the dot product, times 180 divided by pi. Okay, so this is our 3D. And if you want to implement the 2D, it would just be the same code, only that we would only be using X and Y. We would eliminate Z for the 2D. The reason that we would need the 2D is because when let me debug it first. Because when at a certain angle, the molecule could be 100, or could be 90, and if you rotate the angle, the molecule or anything, the angle won't change, but the angle would. I'm sorry, I didn't say that right. On the program, the angle won't change. It will still tell you that it's 90 degrees, but in reality, since we moved the molecule, we rotated it or rolled it, the angle needs to change. So that's why we would implement the 2D as well. Unfortunately, we will be able to implement it because there's some kind of error down here where everything is scrambled up. So we're going to try to see if it at least changes our angle. So what we're going to do is we're going to go to bond, and we're going to go to C, and we're going to go to screen modes and select angles, and we're going to try to get this one and then try this one. And as you barely can see, the angle does change, and it does tell us what kind of angle it has from this, so if we would roll it, we would want to go to angles and then click on this one and on this one, and as you can see, nothing changed. But if we put the 2D code, we could actually click it again, and then we would actually see what the angle of this molecule would be at this type of view. Okay, so just to do that, we would just copy and paste. We would copy the code. I'm sorry, I already have it here. Paste, and then we would just remove the Z's. Okay, so that is all we would have to do for this one, and we would also have our 2D angle to work with. Okay. So that is all for my project, and thank you.